Hey, hi, and welcome back. So in previous two videos, we discussed this 7-segment LED display, and along with that, we discussed the BCD to 7-segment display driver IC, okay, which was CD4511BE, okay. So now you have the background knowledge of both the components, and now it's time to discuss how we need to connect them with the microcontroller. Alright, so without wasting any time, now let's start with this video, which is about understanding circuit of 7-segment display section. So now let me tell you what you're going to learn in this video. So the first point is circuit explanation of CD4511B and 7-segment display. So we will see the interfacing between this particular IC and the 7-segment display. We will see what extra components we need to connect around this particular IC, okay. So we will try to understand every single thing in detail regarding the interfacing between CD4511B and 7-segment display, okay. Then the next point is interfacing of 7-segment display section with the microcontroller. So when I am saying 7-segment display section, it actually includes both the components, this IC and this 7-segment display, okay. So we will see how we need to connect this entire section with the microcontroller. Alright, so again this particular video is going to be pretty interesting and I'm sure you will definitely enjoy this video. Okay, so now let's start with this video. So this is basically the circuitry of 7-segment display section, and you already know this is basically the CD4511BE IC, which is BCD to 7-segment display driver IC, and then this is the 7-segment display about which we have already discussed in detail. Okay, so let's try to understand this entire circuitry in step-by-step manner. So first of all, let's start with this part, which is resistor part, and you can see all the pins of this IC like A, B, C, D, E, F, G. All these pins are connected to the respective pins of the 7-segment display. So A is connected to A, then B is connected to B. So likewise, all the pins are connected properly to all the pins of this 7-segment display. And then these two pins, which is 3 and 8, they are actually connected to the ground. We already discussed that we need to connect the cathode side to the ground, and the anode side will be connected to the, the driver side. Now, if you see here, I have connected the resistor between this driver, okay, driver pin and this 7-segment display driver IC, okay. And if you observe the value of this particular resistor, it's actually 330 ohms. Now, if you connect the output of this IC directly to this particular 7-segment display, it will work, okay, without any problem, it will work. But the point is, the intensity of the LEDs will be very high, okay. And when you operate any LED at its maximum intensity, the life of that particular LED will actually decrease, okay. So if you connect these all pins directly to this 7-segment display, then the life of this 7-segment display, it will actually decrease, okay. So you have to make sure that you need to connect the appropriate value of resistor here. And again, if you check the data sheet of this 7-segment display, you will see that the maximum current that we can provide to this particular 7-segment display, or each LED of this 7-segment display, it's actually 20 milliampere. So if you try to provide the current greater than 20 milliampere, then that particular LED will get damaged, okay. So you have to make sure the current which is flowing towards this LED, it has to be less than 20 milliampere, okay. And we have already discussed, the calculation when we discussed the power LED of power supply section. I told you that how we can, select appropriate value of resistor by selecting the current which is flowing through the LED. So you need to consider, the threshold voltage of the LED. Then again, you need to consider the amount of current which will flow through that particular LED. So all this information, current related information, and then the threshold voltage related information you will get in the data sheet of 7-segment display, okay. So you have to check how much current a single LED supports, and along with that, what's basically the threshold voltage of that particular LED. So if you check the data sheet, you will get this value 1.9 volt to 2.4 volt. That's basically the threshold voltage of all the LEDs which are present in the 7-segment display. And again, you have to make sure the current has to be less than 20 milliampere. So by doing this particular calculation, you can select the appropriate value of resistor and you can put it here. And again, it's not like you should go with 330 ohms only. As I told you, depending on the current, depending on the intensity that you want here, based on that you have to select the appropriate value of resistor. Okay, but most of the time I have used 330 ohms or somewhere around that for the 7 segment display. So that's basically the resistor part. Then you already know VDD will be connected to the plus 5 volt, VSS will be connected to the ground. And now let's try to understand the purpose of these two capacitors here. Now actually, generally I told you that the purpose of the capacitor, the first purpose is filtering, and then the second purpose is it's actually going to store the energy in order to provide that energy to the IC, which is connected to that particular capacitor. For example, here this capacitor of 10 microfarad, this capacitor is actually responsible for handling the dV by dt. Okay, so dV by dt means if there is any change in voltage at this particular line because of sudden requirement of current by this particular IC, then that current will be drained from this particular capacitor of 10 microfarad. Okay, if the track is very long, okay, if the track which is coming from PSU, power supply unit, to the IC, I'm talking about power line. Okay, so this is basically the power line. If this track is too long, then you need this capacitor. Okay, otherwise even if you don't connect this 10 microfarad capacitor, it's completely fine. Okay, without these two capacitor, the circuitry will work. Okay, without any problem, this circuitry will work. So you got the purpose of 10 microfarad capacitor. It will be actually responsible for handling the dV by dt, and this you need to connect at you need to connect this particular capacitor only when the distance between the PSU and this IC is too long. Otherwise, without this capacitor also, this circuitry will actually work. Now, why I have connected this 0.1 microfarad capacitor? See, this 10 microfarad capacitor, although we are using MLCC capacitor, still it's going to have little higher ESR. We already discussed ESR actually stands for equivalent series resistance, or it is also called as electrical series resistance. Okay, so this ESR of this capacitor is going to be little high compared to this one. So when you connect two capacitors in parallel, the equivalent ESR, it will get equivalent value of ESR will actually get reduced. So if the IC needs a current suddenly, then this lower value of ESR, with a parallel combination of these two capacitors, the ESR value will be low, and as a result, these two capacitors or this particular capacitor will be able to deliver the current to this particular IC quickly. So that's basically the purpose of connecting this 0.1 microfarad capacitor. We have already discussed this point when we discussed the power supply sections, input and output capacitor. Okay, but in general, if the distance is not too long, then even if you don't connect these capacitor, now not too long means I'm talking about a distance of 8 to 10 centimeter. Okay, if the distance is around 8 centimeter or 10 centimeter, it's completely fine. Okay, even if you don't connect this capacitor, still the circuitry will work. Okay, but still if you are skeptical whether we should connect these capacitors or not, depending on the distance between PSU and your IC, what you can do, you can actually keep the capacitors, but on on PCB, if you observed that without this capacitor the circuitry is working, then you can actually remove these two capacitors. Okay, so but you can actually do the provision of capacitor in your circuitry. So I hope that this point is now clear to you. Now these all pins will be connected to the microcontroller as we are driving this BCD to 7 segment display driver IC with the help of microcontroller. So these all pins, ABCD pins, will be connected to the microcontroller. Okay, and again we are controlling this pin which is blanking input and lamp test with the help of microcontroller. So we need to connect these two pins to the appropriate pins of the microcontroller. So we discussed that we need to the IC that we are using Atmega 328, it actually includes 23 GPIO pins. Okay, so you can choose any of the GPIO pin, whichever pin you like. You can actually go for you can actually use that particular pin in order to control these pins of this IC. Okay, so it's not like you should use specific pin, it's completely up to you based on your circuitry based on the available pins in your microcontroller, you can actually select the appropriate pins to control these pins of this IC. Okay. Now, one thing that you will observe here is I have connected these resistors here. So what are these resistors? So let's try to understand that now. You know, on reset pin of microcontroller, we connected one resistor of 10K value. And I told you that that particular resistor was actually a pull-up resistor. The reason was that particular resistor was pulling the reset pin to the VCC. That's the reason it was actually called as a pull-up resistor. But now if you see here, these all resistors are actually pulling these all pins to the ground. So that's the reason these resistors are actually called as pull-down resistors. Okay. So these resistors are actually pulling these all pins to the ground. That's the reason they are called pull-down resistor. Now, why I have connected these pull-down resistor? So let's try to understand that now. Now, if you don't connect the pull-down resistors on these pins, then what will happen? You know, these pins will be actually in floating state. And because of that, there will be any combination of logic on these pins. As a result, you will be able to see any number on this 7-segment display. It can be 0, it can be 1, it can be 2. Any number will be printed or displayed on this 7-segment display. So you have to make sure that these pins should be connected to the ground by default, so that this kind of situation, you know, these different numbers should not display on the 7-segment display. Okay. So when you connect the pull down resistors on these pins, it actually ensures the logic 0 on all these pins, and as a result, you are just going to get 0 on this 7-segment display. So that's basically the purpose of this pull down resistor. Now again the question comes, why I have selected 1K value here. So there is actually, it's not like you should go with this value only. You can also go for 10K, you can also go for 20K, you can also go for 100K, you can also go for 1 mega ohm. It's completely fine. But the point is, if you go for a higher value of resistor, then you know, these pins will not be strongly tied to the ground. So connecting a 1 mega ohm resistor here, it's actually like keeping this particular pin in floating state only. So there won't be any effect of connecting 1 mega ohm, resistor here. So there should be some flow of current from the from this particular pin towards the ground. So that will, with that, this particular IC will understand that there is a logic 0. If you connect a 10 mega ohms resistor here, then the current which will flow towards the ground, it will be very less. So this IC will feel like this pin or this particular pin is actually not connected to the ground. So you have to make sure you have to choose an appropriate value of resistor so that decent amount of current will actually flow towards the ground. In general, whenever we select the pull down resistor, the general values are like 10K, 20K, you can also go for 4.7K. Okay. So these are actually the general values of resistor. Now, if I select a 1K resistor, then you know what will happen. With this value of resistor, the current which is flowing towards the ground, it will be little higher compared to 10K. So with this value of resistor, the power consumption will be higher. So I will suggest you, instead of connecting 1K resistor here, you should connect, you know, 4.7K or 10K resistor here. Okay. So that will actually reduce the power consumption. Okay. So I hope that this point is clear to you. In the same way, I have connected these pins to the ground for the same reason, that these two pins will be in floating state if we do not connect, you know, these two pins to the ground. So you have to make sure there should be logic 0 here on these two pins, and then in order to enable, in order to provide logic 1 on these pins, you have to generate that logic with the help of microcontroller. Okay. Now, if you observe here, I have actually used 0 ohm resistor. This pin is connected to one terminal of this 0 ohm resistor, and this pin is connected to this terminal of this resistor. So why I have done this? And if you observe, I have actually used the same pins that we used for programming, you know, the microcontroller. Okay. So when I was designing the circuit at that time, actually, I was not sure whether I should use these pins or whether I should, you know, connect these pins directly to the ground. So that's the reason I have just included 0 ohm resistor. Even if you connect these pins directly to the microcontroller's pins, it's completely fine without using this 0 ohm resistor. Okay, so these are like extra components, unnecessary extra components on the in the design. Okay, so I hope that every single thing that we discussed regarding this 7-segment display section is now clear to you. Now let's quickly see the interfacing between the 7-segment display section and the microcontroller. So the interfacing between the 7-segment display section and the microcontroller is very simple. As I told you, there are total 23 GPIO pins in the microcontroller. So you can use any of the GPIO pin in order to control these all 6 pins. Okay, so you can select any GPIOs to control these 6 pins. But in our case, I have selected these, these pins PC2 to PC5. And along with that, I have selected this PB3, which is MOSI pin, and PB4, which is MISO pin. Okay, so using these pins, we are going to control this 7-segment display section. I have used these pins because, as I told you, the MOSI, MISO, SCK pins, these pins will be used only once to program the code in the microcontroller. Okay, which is going to be the bootloader code. So after that, these pins will be, they will be unused. So instead of using some other pins, I actually used these pins. Okay, so that's actually the reason. I hope that you got the interfacing between the 7-segment display section and the microcontroller. The interfacing is very simple, nothing complicated. All right, so I hope that every single thing that we discussed in this video is now clear to you. And if you still have any kind of doubt, then definitely you can reach to me and I will help you with that. All right, so I will see you in the next video, which is about schematic design of 7-segment display. So I will see you in the next video now.